Hi class, I know your lab instructors have gone over the independent project with you. What I'm going to do today, I'm going to go over a sample calculation with you to kind of guide you how to do the calculation part. Alright, so let's get started. So in your lab instructor has already assigned you guys a concentration. You all got a card, and on that card, it was your assigned values. So my assigned concentration are 0.50 molar iron 3 chloride and 0.40 molar hydrochloric acid. So you were assigned a concentration of iron 3 chloride and HCl. Your numbers are different than the numbers that I have here. Okay? So the point of this lab is to make one solution that has these concentrations. Again, your concentrations will be different. Your lab instructor has already assigned you that. All right, now let's go over how we would accomplish that. If you look at the independent project summary, it says that these reagents are available to us. Okay, now what does that mean? So this is the solution that I want to make, and these are the reagents that are available in the lab. Because when you are trying to make something, you have to make it from what is available to you. So these are what is available in the lab. So that's what we have to work with. Okay, now if you read the independent project summary, it says you need to make a 100 ml solution that has these concentrations. And these are the available reagent. These are what we have in the lab. Okay, let's get started. So I know that I want to make a 100 ml solution. And by the way, my drawings are not the best. So what I'm going to take a 100 ml volumetric flask. Okay. I want to take a 100 ml volumetric flask. You can take different glassware. You can use different glassware in the lab. I'm going to use this one. Now, again, the point is I need to make a solution that is 100 ml. And in my case, is going to be 0.50 molar iron 3 chloride and 0.40 molar HCl. Okay? So that's going to be my solution. How do I accomplish this? So remember what was available to me. What was available to me was 3 molar hydrochloric acid and iron 3 chloride hexahydrate that is solid. Okay. Let's do one step at a time. So in the lab, I have a 3 molar hydrochloric acid. Now, in my case, what I want at the very end, I want a 0.40 molar hydrochloric acid. So this is what's available to me, 3.0 molar hydrochloric acid. What I want my final solution to be is 0.4 molar hydrochloric acid. So how do I accomplish this? Look at this. You've seen this in a lecture before. The concentration is changing. I have a 3 molar concentration. I need to make a solution that is 0.4 molar. So what I'm doing here, I'm doing dilution. And you know that every time we are doing dilution, the formula for dilution is M1V1 equal M2V2. So every time the concentration is changing, M1V1, M2V2 is the formula that we use. All right, so let's go over this. And again, I know you already know this, but let me just say this for my own good. M1V1 is your initial concentration and volume. M2V2 is my final concentration and volume. So every time we talk about dilution is M1V1, M2V2. This is my initial, this is my final. And this is the dilution because the concentration is changing. All right, what is my M1? My M1 would be 3.0 molar hydrochloric acid. That's what I have. I don't know how much of it I need to take. My M2, my final concentration that I want, is 0.4 molar. Now, how much of this concentration, how much of this solution do I want? Remember what we said. We want one solution that is 100 ml. That is 100 ml. That's the point of this. Your final solution should be 100 ml. Your final solution should be 100 ml. So, my final volume is going to be 100 ml. M1V1, M2V2, when we do a dilution, okay, my initial concentration is 3. My final concentration is 0.4. I need 100 ml of this solution. Okay, so now, this is good so far. Let's do a little math to figure out V1. To figure out the V1, what you have to do, I'm taking my calculator out, is 0.40 times 100 divided by 3. 0.4 times 100 divided by 3. What I end up getting, I get 13 ml. I get 13 ml. So far, so good? Okay. Now, what does that mean? This means that if I take 13 ml of 3 molar hydrochloric acid and I dilute it all the way to 100 ml, I would get the concentration that I want. Okay, so I take 13 ml of 3 molar HCl. You dilute it all the way to 100 ml because remember, we want our final volume to be 100 ml. Then I would accomplish making a 0.4 ml molar hydrochloric acid solution. So far, so good? Okay, that's the first part. So I know how to make that. But remember, I also have an iron 3 chloride. How do I do that? If you go back to the available reagent, we had a 3 molar hydrochloric acid. That's the liquid. We did a dilution. We know how to make that. This one is a solid. It's a solid. If it's a solid, it's not a liquid. I can't do an M1V1, M2V2. I can't do a dilution. So what am I going to do? What am I going to do in this case? It's a solid. So remember, in this chapter, we learned that molarity is moles per liter. There are two equations that you got to know. Molarity is moles per liter, M1V1, M2V2, that's for dilution. Molarity is moles per liter. Can I use this? Let's go with it. So, the molarity of iron 3 chloride that I want is 0.50 molar. I don't know how many moles that is, but I know that I want my final solution to be what? To be 100 ml. That's really key, that we want the final solution to be 100 ml. Molarity is moles per liter. So what this means is I have the molarity that I want is 0.50. I have the final volume that I want is 100 ml, but molarity is moles per liter. So I have to divide it by 1,000 to get a liter, and I just did. Okay. So molarity is moles per liter. I have the concentration that I want. This is the molarity I want. I know that my final solution should be 100 ml. Divided by 1,000 would be 0.100 liter because molarity is moles per liter. So I had to convert 100 ml into liter. So far, so good. Okay. So what do we get? This is a cross multiplication. So it would be 0.50 times 0.1. If I do that, what I end up getting is 0.050 moles. Okay, so I need 0.050 moles of FeCl3 to accomplish this concentration. Okay. Now here's a little problem. How would you measure 0.050 moles of iron 3 chloride? We can't really measure moles in the lab. What could we measure in the lab? Mass. Exactly. We could measure mass, not so much moles. Okay. So how are we going to do this? Let me move this up a little bit. So I have the moles. I have 0.050 moles of iron 3 chloride that I have. But we just said you can't measure moles. You can measure mass. How do you go from moles to gram? I need you to tell me right now. You know how to do this. How do I go from moles to gram? I use molar mass. Okay. So 1 mole of FeCl3 with 6 water. Now hold on. Why did I end up getting this? Remember, what you have available to you in the lab is iron 3 chloride hexahydrate. So it's a hydrate that is available to you in the lab. So this is what we have in the lab. So I need to use the molar mass of this one. Okay. I'm going to give you a second. Pause me and calculate what is the molar mass of this. Okay, now unpause me. So what did you get for molar mass? Hopefully you got something along 270.3 grams per mole. Okay. So again, that is the molar mass of iron 3 chloride, which happens to be a hydrate, the one we have in the lab. So I have the moles. I have to multiply it by the molar mass to end up getting the grams, the mass that I want. So if I do that, let's do it right now. So 0.05 times it by that. What I ended up getting is 13.5 grams. Okay, so that's what I ended up getting. So here's the calculation. But what does all these mean? Let's go over it. So remember what we want. We want to have one solution, and we want the final solution to be 100 ml. Okay? One solution to be 100 ml. And in my case, we want the final concentration to be 0.50 molar iron 3 chloride, 0.40 molar HCl. Your numbers are different. Don't forget that. So we want one solution that has those concentration. How are we going to accomplish that? Okay, we know how to accomplish that. We just did the math. To figure out how do we do this. Okay, so let me redraw my volumetric flask. Again, you can take different glassware in the lab. I like to take a 100 ml volumetric flask. It makes it easier because I know my final solution needs to be 100 ml. How am I going to do this? The way I'm going to do this, we already did the math. I need to take 13 ml of 3 molar HCl. So I'm going to take 13 ml of 3 molar HCl, and I'm going to add it to that. Okay. What else do I need to add to that? 13.5 grams. Then I'm going to add 13.5 grams of iron 3 chloride hexahydrate. Again, the iron 3 chloride is a hydrate. It has water attached to it. Okay. So based on my calculation, I'm going to take 13 ml of 3 molar HCl. And then my iron 3 is a solid. I'm going to weigh out 13.5 grams of that. I'm going to add it to the volumetric flask. Then what am I going to do? So step 1, add the HCl, add the solid, and then I'm going to add H2O to the mark. Remember, my final volume should be 100 ml. So I'm going to keep adding water until I get to 100 ml. Because my final volume should be 100 ml. So, one more time. I'm going to take 13 ml of 3 molar HCl. I'm going to weigh out 13.5 grams of my iron 3 chloride. I'm going to add them to this. Then I'm going to keep adding water until the mark, because I want my final volume to be 100 ml. I shake it really well, and I have my one solution with those concentrations. Okay, so hopefully this helped. So now you know how to approach this independent project. You have different numbers, but the process is exactly the same. All right, best of luck to you guys.